So let's find the following limits. Let's find the limit as theta approaches 0 from the positive side of cotangent theta, and then the limit as theta approaches 0 from the negative side of cotangent theta. Now, one of the first things that we are going to want to do here is hopefully remember that cotangent theta is equal to cosine theta over sine theta. So that's the first thing that we're going to want to do here is I'm going to say that the limit as theta approaches 0 from the positive side of cotangent is the same thing as the limit as theta approaches 0 from the positive side of cosine theta over sine theta. Now, if we plug in 0 into this function, cosine at 0 is a 1. It's going to approach a positive 1. Sine at 0 approaches 0. So if you remember the sine function, right, the sine function looks something like this. As it approaches 0, as it approaches 0, it does go to 0. So looking at this analytically, our numerator is a positive 1. Our denominator is positive. It is coming from the positive side, but approaching 0. So the denominator is also positive and approaches 0. Positive divided by positive is positive. And again, rules of limits say that if your denominator approaches 0, that makes your function arbitrarily large. So if it is positive and arbitrarily large, the limit as it approaches 0 is a positive infinity. Now, when we look at this, the limit approaches 0 from the left-hand side. All right, so cotangent, we're going to do the same thing. We're going to break this up to the limit as 0 approaches, the limit as theta approaches 0 from the left-hand side of cosine theta over sine theta. All right, so we're doing 0 from the left. Now, cosine of 0 is still a 1. So our numerator is still going to approach a positive 1. Now, sine theta from the left of 0 here. Again, sine theta from the left, it is negative. Right? It's negative and it's going to approach 0. So we're looking at it from this side here. Negative and approaches 0. So rules, right? It is positive in the numerator, negative in the denominator. Positive divided by negative is negative. And again, if your denominator approaches 0, it makes your function arbitrarily large. And by definition, if it is negative and arbitrarily large, it is going to approach negative infinity.